Welcome to today's webinar, 2023 State of Load Balancing, Kubernetes, mTLS, and more. My name is Frank Yu. I'm Senior Product Marketing Manager for VMware, part of AVI NSX Advanced Load Balancer. So we deal with load balancers all the time, and we have a lot of interesting things to say today. I was supposed to be joined with my co-host, Nathan McMahon, but unfortunately he is out with the flu and he is not able to attend. So you're going to have to deal with just me today. But hopefully I'll be able to provide some good insights and some great conversations. A couple housekeeping things before we start this webinar. If you have any questions, we will answer them at the Q&A period at the end of the presentation. So please enter your questions in the chat window for the questions, and we will certainly then talk about anything that you want to in terms of any follow-up questions. Also, housekeeping, this webinar will be available on demand afterwards, so please don't forget to share with your friends and colleagues and see what they can learn from this as well. So let's go ahead and get started. State of Load Balancing 2023. It's not 2023, but there's a lot of great things happening. And load balancing, my gosh, we deal with modern architectures. And when we talk about modern architectures, it's important to understand that load balancing is a technology that's been around for a long time. It's been around since the late 90s. So it's over 20 years old. And it has really progressed in terms of its capabilities, and it's continuing to progress. We'll hear about that in a little bit. But in terms of where it is in terms of maturity, it's a mature technology. There's not a lot of major changes happening in terms of features, functionality, and what we expect of it. So you can see in this diagram, we're talking about the typical Gartner analyst hype cycle diagram, where technology starts at the very beginning on the left-hand side, and you get this inflated expectations. Wow, it's going to do this, it's going to do that. And then we get to a point where, oh my gosh, it's a pain. It's not doing what we expected. But eventually we get to the point where we get to this plateau of productivity where it's really useful, and we found its niche, we found its purpose, and we know what it's going to do for us, and we know how to implement it. And that's kind of where we are, getting close to that with load balancing. But there's a lot of challenges with what the load balancing technology has done and is what's done over the years. So 20, 30 years is a long time. And over the time, there's been changes. And these changes mean that, first, application architectures are not stable. We've gone from these legacy data center model application architectures, where we have these data centers in what we call these silos, where it's top down, things come into the edge of the network through these gateway routers, go through these firewalls or other security devices, go through the load balancer to get to the application. It's a very tiered top-down structure. That's changed. Now we have this cloud, multi-cloud, software-defined, virtualization. And this means that applications are popping up all over the place, not just applications migrating from, for example, the data center to a public cloud like AWS. But we have these applications now being deployed in multiple locations in public cloud, AWS, Azure, Google Cloud, GCP. And we have these private clouds, software-defined data center using virtualization software, such as we have at VMware with our NSX product, which is a great product, just pitching out there because. But these applications sit in all these different locations. It's the same application, but we still need to manage and protect it as if it was a siloed application, because it's still one instance logically that people are accessing. So how do we load balance to it? How do we protect it? How do we deal with that? And software defined also brings other challenges. For example, now we're talking about things like elasticity. And when I say elasticity, I mean on-demand resourcing. It's a cloud term. And so when we talk about on-demand resourcing, These applications and their servers and the resources are scaling up and down to meet demand. Great example is, let's talk about the holiday season. And holiday season, and there are multiple holiday seasons, but Black Friday, you have people going online, or Cyber Monday after Black Friday, and they're going online in droves to get these great deals. Amazon has Prime Day. There's Friends Day in China. There's lots of different options for these things where it occurs. And now your application has a scale to meet the demand, but you don't want to buy the resources in advance and keep them for 12 months if it's only going to be used for 3 or 4 days of the year where your resource is scaling 3, 4, 5, even 10x or more. So you do this on-demand scaling. You just purchase what you need or rent what you need for that time. And you can do that now with this cloud and software-defined model because you have that flexibility. The load balancer has to scale with that as well, has to integrate with all the other pieces, and you have other technologies involved. So multi-cloud and software-defined virtualization has changed how we're doing load balancing. So this is not new for 2023. That's not new for 2022. It's been evolving for the past 10, 15 years. But it's something we want to keep in mind, and you'll see this being referenced as we continue talking through this presentation. Number 2, and here's a big shift. Containers, microservices. Wow. I've been somewhat surprised about the uptake of containers and microservices in production environments over the past year, 2 years, 3, even 3 years possibly. It's amazing how much people are adopting and accepting this as the current technology and this technology moving forward. So when we talk about containers, the challenge now is these applications are not these, using the industry term, monolithic applications where you have this big application sitting on this big server sitting somewhere. You're taking that big application and you're breaking it up into a dozen, 2 dozen, 3 dozen little pieces that in each one has a little function related to the coordination of the application. The front end, in terms of the middleware, in terms of the back end to get to the database. And now you have to load balance all those components. Not just this one big monolithic application, which is what we did in the old days, but now all these dozens of components need to potentially be load balanced to get that availability, get that resiliency, to get that scalability. And to do that, we need to coordinate with these applications. And when I say coordinate with these applications, that means that we have components. We need components. And so, for example, VMware with our NS6 Advanced Load Balancer, and I'm just using ours as an example so I can describe it. So others do things maybe in a similar way, different way, but I'm just going to use ours as an example to describe it, where you'd have the load balancer or the management telling the load balancing engines to do certain things to integrate with the container infrastructure. And when I say integrate with container infrastructure, we're primarily talking about Kubernetes. Kubernetes is an orchestration system designed for containers to be able to manage those microservice instances, what we call nodes, and to be able to spin them down, to be able to move them around appropriately. So to work with this orchestration engine now, the load balancer management needs to communicate to the Kubernetes, and we use something what we call ingress controller. Ingress controller means that the load balancing management is integrating or tying into the Kubernetes infrastructure through this ingress controller aspect. It's basically an API, if you want to call it that, or like an API-like in terms of functionality, where now it can send and receive information to the Kubernetes infrastructure. For us, an SX Advanced Load Balancer, also Avi, we call ourselves Avi because we were acquired a few years ago. We have what we call Avi Kubernetes Operator, AKO, which is our ingress controller. And this ingress controller can now do things like when you spin up a new instance of a portion of an application, we automatically add it to the load balancing pool because we get the information from the Kubernetes engine saying, here's this instance being spun up, it's for this application, it's going to be that IP address, and it's going to be responding on this TCP port. And we will take that information out to the load balancing pool. And we can also send information back. Tell the Kubernetes engine, we have this load balancing pool created. This is what the information is. Here's the virtual IP that's going to be associated with it. Here's the resource allocation associated. We can send lots of information back and forth, but the integration into Kubernetes becomes important. And the reason it's important is because there are a lot of challenges with managing this and managing container infrastructure with the dynamism. Because now we're going to, and I'm going to throw more terms out here, an agile development process, DevOps, CI/CD, continuous integration, continuous development, where things are being changed on a very rapid, regular basis. And because of those changes, we need to make changes in the infrastructure and configurations. So when we talk about microservices, this is a big, hot thing. It's popular today. It's going to continue to be popular as we move forward. Challenges with latency ingress services. So we have these nodes and these pods. These pods are the individual microservices within the nodes. And they need to talk to this ingress controller that I described. And then you can see above it, I have these load balancers. Layer 4 load balancers, active standby. But not only am I doing load balancing in my load balancer technology today, because we also have this other term, ADC, Application Delivery Controller, which is basically a load balancer with extra functions and features. In this case, Web Application Firewall, DNS management. DNS management could be global server load balancing. We have IPAM, IP address management. This can all be done through the load balancer, and this needs to be integrated into the Kubernetes infrastructure as well. So this can be a challenge if we didn't have the proper ingress controller, number one, and two, just because of the way load balancers are designed, it can be hard for us to manage because there could be a lot of manual operations and policies that we need to deal with. So we have GSLB, Global Server Load Balancing, which is disaster recovery, active for multiple sites, which is important in this multi-cloud world that we discussed earlier. So we can direct traffic appropriately through these various clusters. So we need multiple solutions, or we have multiple solutions in terms of load balancing, ingress, GSLB, DNS, IPAM, web application firewall, et cetera, et cetera. This is going to make it very complex to manage. Complex to manage, just getting our heads around everything that's going on, the interactions, and troubleshooting. Can you imagine troubleshooting this? This can be completely hard, painful to do. Observability. You can't troubleshoot, you can't predict, you can't make changes if you don't know what is happening in infrastructure. If it's a black box, then you have a problem. We need to be able to see what is happening at the different points. And because there's so many changes and so many components, you can't do this manually. It has to be automated to some degree. You have to have scripts, policies, other things, tools to automate things so that when we talked about Black Friday again, and you need scale-up resources because now people are starting to hit your website and trying to buy the hot toy for the holiday season. Need some way to automatically scale those resources to bring up more instances of the front-end web application server, the shopping cart engine, the database, and fulfillment, and all the other pieces without having to manually doing it. Because if you're manually doing it, it's going to take, what, 30 minutes, an hour, several hours? By the time you do that, you've lost your audience. You've lost your customer base. So we need to automate the process to make it quick and efficient and reduce that human error in the process. So really, truly what we want to do is we want to consolidate all these application services through the load balancer, because the load balancer is that key point. If you know load balancing, the load balancer is the key point for access into the application, and a lot of good things can be done because we are that key point or bottleneck into the application infrastructure. We can provide that integrated solution for all those components that we talked about. Security, ingress controller. We can do operational simplicity because we're doing it through one management interface and making it easy for us to do everything through one interface. And that also gives us the ability to have rich analytics and observability to get the information from the load balancer that tells us all the things going on about the application from a performance perspective, from a security perspective, and give us those insights that we can properly manage this. And last, automation. Provide automation through Kubernetes to do that auto scaling that I described, to have a closed loop system that can automatically determine, okay, I'm going to set a policy that says if resource utilization hits 70%, spin up a new resource. If resource utilization hits 20%, take a resource out of the pool and do it automatically based on the policies that are defined. And this becomes important for us to really manage that Kubernetes infrastructure for our applications. Integration is another big thing that is happening in terms of the load balancing technology. We've gotten to the point where load balancers were these standalone devices that sat in the network and did their job. They created pools, provided availability, scalability, agility for your application environment, and they did it on their own. But as I just described with the Kubernetes environment and containers, you have to integrate now, or you can integrate with lots of other pieces. So here I just took a random sampling, not completely random. I took a sampling of some technologies that are used in these IT ecosystems, microservices, and before microservices with virtualization, we had virtual machines. We have automation engines. We have containers, applications, and applications within these containers that have APIs and other pieces. We do encryption. We talked about hypervisor management for virtual environments. Security-wise, we have firewalls, not just firewalls. We have IDS, IPS, intrusion detection, intrusion prevention. We have endpoint detection, endpoint protection, detection and prevention. We have DNS, public clouds, private clouds, hybrid clouds, all these sorts of random clouds that exist in the internet today. We have databases. Load balancing databases, absolutely. Object storage is a great place for you to be load balancing, and there's no reason why I should say you should be load balancing your object storage databases today. Data analytics, machine learning. There's so many components within the IT ecosystem in terms of functions and services. And the load balancer, because of its key location in the network, touches them all. Either performs the function or works with other pieces to help enable those functions. So therefore, there needs to be a lot more integration with these tools. Great example, let's talk about security. And we have these security management systems, these SIEMs. And these security management systems coalesce log information, security alerts, other pieces from other devices. The load balancer is a security device. It has web application firewall. It has other functionality that we'll talk about in 1 second. But it does all these security things, and it needs to integrate into the security management systems. It needs to send logs and send alerts, and needs to send information about, hey, I see this attack cross-site script attacking this website coming from this IP address at this time and was this long or whatever the case may be. The load balancer needs to tie into all these other systems and integrate. It's critical that we play within this ecosystem of other technologies to really build that network and build that self-contained, self-organizing, can I say, network of things to help manage your network better. And let's talk about security. Security is the hot topic. Has been this past year, has been probably the year before. It probably will be for the next 2 or 3 years. There's a lot of things we can talk about security. Let me bring up one interesting point. Bots. Bots are a popular topic nowadays. We had botnets in the past, and we had all these other things, but now we're really concerned about these bots because according to some studies, 40% of the traffic on the internet is bot traffic. It's not human traffic. What's this mean? It means that there's a lot of automated things doing good things and bad things to your application. So there are good bots, like these web crawlers. You're not going to get into the Google search engine unless you allow Google bot to access your website. There could be bots for partners. There could be bots for site monitoring. So you have a site monitoring solution in your environment, and it's setting little probes and pings and checks to make sure that your applications and your network devices are happy. That's basically a bot sending requests and getting feedback. There could be things like copyright checks. So for example, on YouTube, if somebody is stealing some content, whether it's video or audio content, without paying the proper licensing or royalty fees, that can be checked through these copyright check bots. There's RSS feeds. There's a lot of good bots out there, but on the other hand, there's a lot of bad bots as well. Web scrapers, spam, click fraud. There could be competitive bots that are scraping, for example, if I have a business, they're scraping my website for my pricing. And then they're going to take their prices and undercut me 5%. I change my pricing, their bot scrapes it, and they're going to undercut me. I have a problem. There's all bad bots that are doing things to attack, to find vulnerabilities. So bots are becoming a big thing, and people are trying to find ways to identify or to separate the good bots from the bad bots, number one, and two, block the bad bots. Don't let these bad bots in and access my applications. So bot detection and mitigation has started to become popular. You might have heard or seen some technologies out there that are starting to do this. And you're going to continue to see this, and it's going to continue to increase. And again, I keep on coming back to this. The load balancer is the initial point of bottleneck access to the application. It is a perfect place to provide bot detection and mitigation. So expect to see more with bots detection and mitigation within load balancing technologies, not just from VMware and Navi, but of course with other vendors as well. This is going to be a general trend that we expect to see. Encryption. It's almost like the elephant in the room talking about encryption, because we always talk about encryption and the pieces with it. So my discussion point for encryption for this year and upcoming is TLS 1.3. TLS 1.3 was officially released in, I think, August 2018. It is a secure version, or a pretty darn secure version of encryption, TLS, transport layer security, for having encrypted connection through your web browser to various sites, right? According to this chart, and this is current, I just pulled this the other day, 60% of websites support TLS 1.3. Well, my response is 40% of the websites on the internet do not support TLS 1.3. It's been out for, what, 4 years now? And there's still 40% of websites on the internet that do not support the secure encryption model, fixing a lot of vulnerabilities and holes and issues with the previous models. TLS 1.2, pretty good, but it's got issues. 100% of the websites support it. Now it gets really scary. TLS 1.1, insecure. TLS version 1.0, really, really insecure. And before TLS, it was called SSL, Secure Sockets Layer, version 3.0 and version 2.0. Yeah, they still exist on the internet. Are you kidding me? TLS version 1.0 and 1.1 is supported in what? Over 30, let's say 35, 36% of the websites on the internet. So if I have a browser and I tell the website I want to communicate encrypted, but I want to use TLS version 1.0, 35% of the time, I'm going to get a connection through this insecure connection with lots of vulnerabilities. So here's the challenge. Why, after 4 years, are we not, is not 95 to 100% of the websites using TLS version 1.3? That's question number one. Why are they taking their time upgrading or supporting this current version? And number two, why are the ones, for example, TLS 1.2, 100% supported, but those websites also are willing to downgrade their encryption model to a less secure version? Why are we still allowing these less secure versions that basically should not exist at all exist on the internet? The good thing for load balancers, and why I talk about this from a load balancing perspective, is, again, load balancers are the front end to the application servers. What does this mean? It means that the load balancer can adjust the encryption protocol support for the application no matter what the application does. In other words, I can, through the load balancer configuration, I can say only support TLS version 1.3. And I don't care what the backend application supports, because I can communicate it on it with an internal channel that is less secure, but I know it's going to be safe. I can force the client to connect to the application using TLS 1.3. And I should. This is a huge benefit for load balancers also, because now the application developers are saying, I don't want to upgrade. It's going to take time. It's going to create a change window and outage, and I have to upgrade all these servers. And it's just something I don't have the resources to do. It's low priority. I can make the configuration change on the load balancer to force it to do that, while the application developers can then take their time, not too much time, hopefully not 4 years or 5 years to make this change, but give them time to implement a process so that they can upgrade their servers appropriately. So the load balancer can be key to helping us manage this protocol support and protect us against these less secure connection models that are still out there. I'm going to stay on TLS for another topic here. mTLS, mutual TLS. This is a hot topic now. Mutual TLS, what is it? So when we talk about creating a secure connection, look on the left-hand side of this diagram or image. And you can see typical TLS client talks to a server, makes a connection to a server, server sends a certificate, and the client validates that certificate to some certificate authority to say, yes, you are who you are. I'm going to connect to the VMware website. I'm going to connect to the VMware website using an encrypted connection. the VMware website can send me a certificate saying, yes, I really am VMware. Here is my passport or my license or whatever you want to call it to say, I am who I am. I'm going to validate that through some third-party site. Let's say it's a passport. I'm going to validate it through the government that issued that passport and say, yes, this was properly issued. And now we can communicate. Whoops. And mTLS does the same thing, but now the server is going to authenticate the client. The server is going to say, okay, you're connected to the VMware website. Are you truly a person or a legitimate thing accessing my website? So me as a client, I'm going to send them my validation, my passport, my driver's license, my version of my certificate to say, yes, this is who I am. And the server is going to validate that, yes, this is who I am. And send the data. Then we start communicating. Why is this useful? Well, let's look at the use cases that I have described here. So TLS is primarily used for secure client server connections. General internet, me going to a website to do e-shopping. I'm going to some e-commerce website and the server doesn't really need to validate me. All they want to do is make sure that I go on, fill up a shopping cart and then check out and spend some money. And they'll validate through the checkout process and other pieces, but they don't need to validate during the encryption process. mTLS, B2B connectivity. So if I am partnering with a third-party vendor and we have two servers that communicate with each other, I want to make sure that communication between those two servers is really between those two servers. So the client is now another server. Or the client could be someone within the operations team or logistics team or something that are accessing my server. I want to make sure that truly is who they are when they connect to my system. Think of it kind of like a VPN access. When I connect to a VPN server to get access to the network, I validate who I am and the VPN server validates who they are. There's mutual authentication. And then the second piece is microservices. We took this application and we broke it up into these nodes and these little tiny components. So now this application has been exploded from one instance of a piece of software to, again, possibly dozens of instances, and they all have to communicate with each other. I want to confirm that those communications between those instances are appropriate, that nobody from a third party is trying to access an instance when they shouldn't be. So I'm going to use mTLS, mutual authentication, to make sure those two instances, those two microservices should be properly communicating with each other. So mTLS is very useful, B2B is very useful in container microservices. And the question here is the trend. I was discussing with my colleague who is unfortunately sick and can't attend today. Is mTLS going to extend to this client server model that we see on the left? In other words, is TLS in general going to go away and get replaced by mTLS? His response is absolutely. There's no reason for it not to. Why not authenticate both sides? And there are possible reasons why you don't authenticate both sides, because there's overhead, number one, to do the authentication and the resources and other pieces. And two, the question is, do you really need to? But even if you don't need to, why not? So there's definitely a possibility for us to authenticate and provide mTLS and have it become pervasive throughout the internet. And if that happens, then of course the technologies used to do the encryption, such as the load balancer, which does encryption termination, as we discussed, is a key point to provide that mTLS functionality. And we need to do it in a proper manner. Let's talk about this other thing that's been really popular in the security world, definitely in the past year, this thing called Web Application and API Protection, WAAP. WAAP is important because it's now taking the concept of your quote unquote, and I'm using air quotes here that you can't see, this web application protection, such as the web application firewall, and extending it to just web application as a whole and API protection. So these APIs, all these communications that we see between these microservices and the containers, all these other pieces with the web applications, we are now moving into an API-driven world. And this API-driven world requires us to manage not just the web application, but the APIs that they're communicating along. So the good thing is that I would say probably 95% of the APIs that exist today are still HTTP transport based. They are just some sort of format or form for communication, but still using HTTP transport. Why is this a good thing? Because we can still leverage existing technology, such as the web application firewall, to do inspection for APIs. Because the web application firewall can do the content inspection for HTTP traffic, HTTP and HTTPS traffic, and you just need to define the proper policies and rules associated with those APIs. So we expect to see a lot more in terms of web application and API protection moving forward. We hear about it a lot lately. It's continuing to grow, but also keep in mind that the load balancer can be and should be a key point in your discussions when you talk about this web application API protection, this WAAP. And when we talk about this WAAP, web application API protection, we need to talk about why it's really important. And that's again, because the load balancer is that ingress point into the application infrastructure. It's that first line of defense. And it can provide the app protection and API security from the ingress point for all incoming traffic from the outside. So most attacks that you see coming into your application infrastructure, whether it's monolithic applications or microservices, are going to be coming through this external point. And the load balancer is this first line of defense into the infrastructure, whether it's cloud, private, software-defined data center, or whatever the case may be, into your applications. And it can really provide that full functionality through the features of being a full reverse proxy, providing that transaction visibility, being content aware, providing the understanding the application models, being dynamic, etc., to really protect our applications and APIs. So ultimately, the trend that we see with load balancers is becoming, yes, they are load balancers. They do the pooling of application service, provide that resource availability, scalability, agility, etc. But they are equally becoming as important from a security perspective to protect your applications because of their point of control and their content inspection as the web application firewall, doing the bot management, API protection, giving you that visibility, having feeds for threat intelligence for real-time or near real-time information to update your policies, and protect against all types of attacks, whether it's web traffic, APIs, file uploads, bot detection and mitigation. So the load balancer we expect moving forward is going to become much more important and should be a decision-making process within not just the network teams, but also the security teams to determine exactly how and where does it fit within the infrastructure and within the management in the organizations. So let me finish this off and talk about predictions. What are predictions going to be big for within the next 12, 24 months? And I have 4 predictions here. Number 1, orchestration and automation. We discussed this in this presentation already, talking about integration to Kubernetes. I expect us to see a lot more integration to orchestration automation systems. For example, at VMware, we have VRO, vRealize Orchestrator, and VRA, vRealize Automation. And tying into these orchestration and automation tools, not just within the VMware family, but with all the other vendors that exist in the IT world. Tying into orchestration and automation to remove the human element, to remove the possibility of human error, to automate tasks that are repetitive. And my colleague, he liked to say, orchestration and automation is great, and you can automate all the functions you do constantly. You can automate a lot of good things, but don't forget you can automate bad things as well. So be careful and be cognizant of your decision-making process to automate things that make sense and to review your policies appropriately. Next thing, HTTP3 or H3. Moving HTTP from TCP to UDP is the primary goal of HTTP3. It makes things much more efficient in terms of resources and response, because now you don't have this TCP connection process. You don't have these TCP ACKs. You don't have the TCP retransmit process and all these other pieces going on, window sizes, frame size. So UDP is a little more flexible in terms of frame size, you know, in terms of 1500 byte packets versus jumbo frames. HTTP3 is slowly getting uptick. A lot of websites support H3 and it's continuing to slowly grow. At some point, there's going to be some sort of inflection point where it's going to grow rapidly. It's probably going to grow rapidly within the next, I believe, my prediction is the next 12 to 24 months, where you're going to see a lot more things supporting websites and things supporting H3. A lot of major websites, obviously, like Google, for example, supports H3 because they kind of back it through the QUIC protocol, which evolved into H3 and other pieces. So there's a lot of drive to get H3 out there and make things more efficient. And then one of the questions we have, and I have, is, does that mean that maybe we're going to get rid of TCP? Because everything, if HTTP can go to UDP-based stateless model, does anything still need to be TCP? And there it says probably yes. There's going to be use cases for UDP-based communications like H3. Excuse me. And there are going to be situations where we still want TCP-based communications. It depends upon the use case, but I expect to see a lot of uptick with H3 over the upcoming time. My third prediction and point, and as a broad point, visibility. I've been doing networking and building IT infrastructure and things for over 30 years, and I'm showing my age when I say that. But back in the old days, as old people tend to say, back in the old days when we built our networks, we didn't care about visibility. We were just trying to build the network and get it working. And as long as it worked, we were like, okay, let's move on. And people still tend to feel that way about building networks. Let's get it out there, let's get it functional, and we'll worry about everything else later. We're at a point in terms of IT architectures, designs, especially when we talk about these containers, microservices, and virtualization, and hybrid multi-clouds, and all these other pieces and buzzwords that I'm going to throw out there, where visibility is becoming critical. So there are two inflection points, I think, that are driving this visibility prediction. Number one is what I just said, with all these different environments, flexible environments where we need visibility to be able to manage it properly. And two, we're getting at a point where we can build and we now have the time and effort to think about the visibility and be able to manage it, because the operational aspect without visibility is becoming so painful that we were saying, yeah, we're going to build it, but I don't want to manage this thing because I can't see anything. I need visibility into it. I need to know how my applications are performing. I need to know who's connecting to what, how often, when. I need to know about resource allocations, failures, events and alerts and security. I need that visibility. And it's becoming a point where this visibility and the analytics that goes with the visibility is reaching that threshold where we have to have it for our networks and our applications to be operational. Again, load balancers can be a great point for this because they are that connection point into the application, and there's a lot of rich information available through the load balancer to provide that visibility. The last piece, and this ties in from the visibility and the orchestration automation, AI/ML, artificial intelligence, machine learning, whatever terms you want to use, and people call them slightly different things or define them slightly differently. But in general, some sort of machine thought process, number one, to do things like helping that automation. Okay, I'm going to set up a real simple policy that says, like I mentioned in my use case before, if resources reach a certain threshold, 70%, I'm going to add more resources, do it automatically. But now we can also get to the point where the machines can kind of learn and discover and identify. So it's not about when resources hit 70%. It's going to have a soft spot to say, okay, when things slow down for the user, then I'm going to add more resources. And I might add resources in different aspects to try to alleviate or mitigate that slowdown. So when my response time goes from 100 milliseconds to 600 milliseconds or a second and a half, 1500 milliseconds, the AI is going to say, something's wrong, something's not quite there, and I'm going to make some changes to fix things. Or a user can't access X, therefore the AI is going to say, okay, I'm going to move that application or resource X to a different location or do something so that the accessibility can still be provided. AI ML, again, hot topic past few years, but it's still in the very emerging stages in terms of adoption and functionality. But because of the orchestration automation that I mentioned here, because of the visibility and analytics, I believe this AI ML concept of driving a self-learning engine into the process is going to become much more popular over the course of the next 12 to 24 months. So these are my predictions, and hopefully they're good predictions. We'll find out what happens. So at this point, let's move to the Q&A and see what kind of questions people have. So give me 1 second while I look up the questions and take a quick glance at them. All right, let me see here. I have this one question, and don't forget, if you have more questions, please go ahead and put them in the Q&A window through the interface, and I'll be happy to try to answer them. So the first question I have is mTLS available for users in common browsers today? And the answer is yes. If you want to start using mTLS, and a lot of websites support mTLS, but how about you as the user? Can I configure and set up mTLS for me to be able to use it? And the answer is yes. The answer is a short yes, but it's a long yes, because there are some challenges with doing mTLS on the browser. So number one, most browsers like Chrome and Microsoft Edge and Safari can use the OS's certificate, Windows or Safari or Mac OS certificates to use as a client certificate, but you still need to configure that through the browser. So there needs to be some sort of manual configuration configuration changes that you need to do through the browser to say, yes, I'm going to use this certificate and I'm going to support mTLS and do client certification. And then you have Safari, which has the issue where it doesn't support the OS certificates today. So you actually have to import your own certificate into the browser to be able to support mTLS. So the short answer is yes, you can do it. The long answer is not instant or turnkey or transparent to the user today. Probably in the future, they'll make that more efficient as mTLS adoption increases, but it is out there and they are improving it over time. Okay, let me look at here. I have another question. When talking about microservices and incorporating the load balancer, does the load balancer also need to be a container or microservice within that environment? And the answer is no, it doesn't. It can sit on top of the microservice containerized environment as a virtual machine. But really and truly, to take advantage of the full containerized infrastructure, it does make sense for the load balancing component. With NSX Advanced Load Balancer, ALB, we call it the service engine that does the actual load balancing. It can be containerized. So making the load balancing containerized and fit within that full Kubernetes infrastructure without having to make an outside call to virtual machine components can be very beneficial and make things easier. So it does not need to be, but it makes sense if you can incorporate it with that one infrastructure, not having to tie other pieces. Let's see, I have time for one more question. And the question is there a way to force TLS 1.3 connections to protect the client application? And I'll partially answer this already. And yes, you can. And this is, again, where the load balancer comes in play. The load balancer is going to sit in front of the application. So let's say the application only is old legacy application. The developers don't want to upgrade it or do any patches to it, and it only supports TLS version 1.0. Now, we all know that is horrible from a security perspective. There's so many vulnerabilities, and that web server will be compromised in the near future if they put it out as such. You can take the load balancer, have it sit in front of the application server. And that communication between the load balancer and the application server is going to be a dedicated connection through the private network, so nobody can access it. So we can make that connection between the load balancer and the server TLS 1.0. That's fine. We're comfortable. We trust it internal network unless they break into the network, and then we have other issues beyond this TLS version. So TLS 1.0 between the load balancer and the application. And then for all of the connections coming in to the application through the load balancer, the load balancer can say, hey, between you and me, between the client and the load balancer, we only support TLS 1.3. You have to communicate to me with TLS 1.3, and then I will talk on your behalf to the application server behind me using TLS 1.0. So the load balancer is a great way to mitigate a lot of security issues, not just TLS version numbers, but it could be other issues, for example, using the web application firewall to protect against the OWASP top 10 attacks, cross-site scripting, site injection, all these other pieces that are available, SQL injection, that our applications can be vulnerable to. The load balancer, because it sits in front, access reverse proxy, is a perfect place to provide additional or advanced controls to secure the application and protect the application against vulnerabilities that it might have that we can now defend against using the load balancer as that, I'm going to say gatekeeper, not quite, but as a gatekeeper to the application and protecting it from the clients trying to do bad things. So I think that's all for today. Again, thank you very much for attending. This recording will be available on demand later, so you'll be able to share with your friends and colleagues. And I look forward to talking to you on a new webinar. Thank you very much and have a great day.